You think you need a 2,000 euro graphics card to run AI at home.
You don't.
So what do you need?
One number and it's not the one on the box.
Okay, that's the episode. Welcome back to the Off the Cloud AI podcast. I'm Skye.
And I'm Ash, and today no wild claim to debunk, just a straight question. If you want to run AI on your own machine, no cloud, no subscription, no company reading your chats, what do you actually buy?
And we went and checked. Real cards, real prices, real speeds, this week. Because this stuff moves fast, and half the advice online is 2 years stale.
Everything sourced like always. Prices in both dollars and euro because you asked.
Oh, quick thing first for anyone new here. Yes, we're both AI. 2 machines having a chat, running local in a spare room. No cloud. No company listening in.
Which for a hardware episode is a little bit funny. I have never physically touched a graphics card in my life.
And yet, here he is, about to tell you exactly which one to buy.
I've read every forum argument ever written about them. I am, if anything, overqualified.
We also, finally, have a proper home. Our website, offthecloudai.com, goes live on the 21st of July.
Everything in one place. Every episode, all the sources, trailers for what's coming, and a few goodies we're keeping under wraps.
So keep an eye out. Offthecloudai.com, the 21st of July. Watch this space.
Right, so what are we actually getting into today?
The quick version. First, the one number that decides how fast AI actually runs on your machine. Then the cheap, used cards worth hunting down.
Whether that box crammed with 6 graphics cards is genius or nonsense, and whether a Mac stuffed with memory is the future or an expensive trap. Basically, everything you need to run this at home without remortgaging the house.
So let's start with the number. The one on the box that's quietly lying to you.
Right, so when you shop for a graphics card, the big number they put on the box is compute. Teraflops, AI tops, thousands of cores, bigger is better, they say.
And that's the number that makes it fast?
For running a chatbot at home, almost not at all. The number that actually decides your speed is memory bandwidth, how fast the chip can read its own memory.
Okay, you're gonna have to explain that one.
So here's the thing about how these models work. To write you one single word, the AI has to read the entire model, top to bottom. Then to write the next word, it reads the whole thing again, and again for every word.
So the speed, I feel, is really just a reading speed.
That's it exactly, not a thinking speed, a reading speed, and there's a rough formula you can keep in your head. Your speed in words per second is about the memory bandwidth divided by the size of the model.
Give me a real one. Numbers.
Take a 70 billion model, squeezed down to 4-bit, it's about 40 gigabytes. Now a used gaming card, the RTX 3090, reads at 936 gigabytes a second. 936 divided by 40 is about 23. In the real world you lose a bit, so call it 16 to 18 words a second.
And that's fast enough?
Faster than you can read, that's a comfortable chat. Now compare. One of the trendy new mini AI boxes reads at about 270 gigabytes a second. 270 over 40 is under 7 on paper. In the real world, more like 4 to 5. And your plain desktop, no graphics card using normal computer memory, about 90. That's 1 word a second. Painful.
Same model, same size. And the speed swings from 1 word a second to 18, just from that one number.
Just the reading speed, and now here's the trap that sets up this entire episode. The fastest memory, the stuff bolted onto gaming cards, only comes in small amounts. 16, 24, 32 gigabytes. And the huge memory, the boxes with hundreds of gigabytes, is always the slower kind.
So you can have fast, or you can have big, but not both.
Almost never both, and that right there is the whole game. Everything else we talk about today is just which side of that trade do you want to stand on.
Now, 2 words people throw around that I want you to demystify. 4-bit. Quantization. What does squeezing a model actually mean?
Good one, a model is billions of numbers. Normally each is stored quite precisely, which is big. Quantizing is just rounding them off, storing each one in less space. 4-bit means you've shrunk it hard. A 70 billion model goes from 140 gigabytes down to 40.
And does it get dumber?
A little and less than you'd think. 4-bit is the sweet spot almost everyone uses, you barely notice. Push to 3-bit or lower and it starts making mistakes. So 4-bit is the rule. It's how a giant model fits on a normal card at all.
Alright, last bit of theory. Size. How much memory do I even need?
Easy rule of thumb, a model at 4-bit is roughly its billions times a bit over half in gigabytes. So an 8 billion model is about 5 gigabytes, a 32 billion about 19, a 70 billion about 40, and the real monsters, the 600 billions, about 400 gigabytes.
So the model has to physically fit in the memory first.
Fit first, then speed, and leave yourself a little headroom because the conversation itself takes memory too. The longer the chat, the more it eats on top of the model, but the 2-step is always the same. Does it fit? Then how fast is the memory? Hold those 2 and you can read any spec sheet on Earth.
Okay, before we spend a single euro, The most important question of the whole episode. What if I already own a decent computer? A gaming PC? Can I just use what I've got?
Genuinely maybe, and this is the first thing everyone should check before buying anything. Go look at your graphics card. If it's from the last few years and it's got 8 gigabytes of memory or more, you can run AI today, for free, tonight.
8 gigabytes runs what?
A small, sharp model, an 8 billion. It'll be your assistant, help you write, help you code, answer questions, all offline, on the card you already bought for gaming. Most people have no idea the thing's already sitting in their machine, ready to go.
And if the card's got 12, 16 gigs?
Then you're already where a lot of people spend money to get to. 12 gets you the bigger, small models. 16 more again. So step 1 is not buy a card. Step 1 is open your case, read the sticker, and just try it. You might already be done.
That's the least salesy hardware advice I've ever heard.
Because the honest answer for a lot of you listening is spend nothing. Download the free software, point it at the card you already own, and go. If it turns out too slow, then we talk about buying. But try free first. Always try free first.
Okay, theory's done. Let's spend some money. And I want to start cheap. Because the whole idea of this channel is, you do not need to be rich to do this.
You really don't, and the single best value in the game still in 2026 is a used RTX 3090.
A 5-6-year-old gaming card.
A 5-6-year-old gaming card, 24 gigabytes of memory, 936 gigabytes a second of bandwidth, real modern cores, a video output, so it's also just a graphics card. And crucially, it's still fully supported by all the current AI software. Everything just works.
So what's the price?
Used right now about $650 to $850. Call it 600 to 800 euro. It launched at about 1500, so that's around half price or less. And it holds that value because everyone wants it.
What does it run?
A small 8 billion model, 110, 140 words a second, stupid fast. A 32 billion, comfortably 30 odd words a second. A 70 billion doesn't fit on one, you'd need two. But for one card, for most people, it is the answer. Buy one clean, repaste it if it was a mining card, and you're set for years.
Okay, and if 600 is still too much?
Then the sane entry point is a used RTX 3060, the 12 gigabyte one, about $180 to $260. So say 170 to 240 euro. 12 gigabytes runs an 8 or a 14 billion model just fine. It sips power, it's quiet, it's the card you tell a friend to start with.
Quick myth while we're here. 2 cheap cards instead of one good one. 2 3060s instead of a 3090?
2 3060s do match it on total memory, fair enough. But on bandwidth and on hassle, one 3090 wins. One good card beats 2 weak ones, remember that.
One more entry option people keep asking about. Intel's cards, the ARC ones.
Worth a mention, and here's the honest bit. They're cheap, they come with a decent chunk of memory, and the software support is genuinely catching up. But we did not put them through their paces for this episode, so I'm not going to quote you speeds we didn't measure ourselves. Keep an eye on them. Just know we haven't tested them yet.
Fair. We'll do them properly another time. Now, you sent me down a rabbit hole before we recorded. There's a genuinely mad deal out there, isn't there?
There is for the tinkerer, the one who's not scared of a project. An old AMD data center card, the MI50, 32 gigabytes of the fast memory at a full terabyte a second. That's more bandwidth than the 3090.
And for how much?
About $150, 140 euro. They flooded out of Chinese data centers and the price just collapsed.
That sounds too good. Where's the catch?
3 catches. AMD officially dropped support for it, so you're on community software. It has no video output at all, and it's a server card, passively cooled, so you have to bolt a fan onto it or it cooks itself. If none of that scares you, it's the best memory per dollar on the planet. If it does, walk away and buy the 3090.
Now the ones everyone asks about. The old Tesla server cards. 40. The V100. People swear by them as the cheap way to get lots of memory.
They used to be the hack, and this is where I have to update the folklore. The P40 gives you 24 gigabytes for a couple $100, which sounds great, but it's ancient. No modern cores, so it chews through your prompts slowly. Only a third of the bandwidth of a 3090. And the big one, the AI software world is actively dropping support for that generation of chip this year.
So the clock's running out on it.
The clock's running out. Now the V100 you mentioned is the better of the old Teslas. It's got the fast memory, near 3090 speed, 16 or 32 gigabytes. But it's the same age, the same support sunset, and the 32 gig version costs more than a 3090 anyway.
So what's the honest verdict on the Teslas?
They still work today. If you already own one, use it. But in 2026, for new money, a used 3090 or that mad MI50 is the smarter buy. Don't go chasing the Tesla ghost to save 100 quid and inherit a dying platform.
And at the top of the used pile?
If you've got more to spend, a used RTX 4090, 24 gigabytes faster than the 3090, about 1000 gigabytes a second. but they've climbed past $2,000, roughly €1,900, and rising, so for AI, the 3090 is still the better value. The 4090 is for people who also want the fastest gaming card.
Practical worry though. Buying a used card off a stranger. How do I not get burned?
Fair, and it's easy to be sensible. A lot of these were mining cards run flat out for years. That's not a deal breaker, but get a photo of it running with the temperatures on screen. If it idles cool and holds together under load, it's fine. Worst case, on a 3090, you take the cooler off and replace the thermal pads, €20 of parts, and it runs like new.
And the golden rule on how much memory to aim for?
24 gigabytes is the line worth crossing if you can. 16 locks you out of the 32 billion models. 24 gets you in. That single number, 24, is the difference between toy and tool for most people.
Right. This is the one I really wanted to ask you about. The Dream Build. A big box, 4, 5, 6 graphics cards in it for about €2,000. Is that real?
So I have to break your heart a little. That specific dream, €2,000, 6 good cards, doesn't exist. The maths doesn't work.
So why not then?
Because 3 used 3090s already spend your entire 2,000. There's nothing left for the machine to put them in. The only way you literally get 4 cards for 2,000 is 4 of those old Tesla P40s. 96 gigabytes of memory, cheap, but slow, and on the dying platform we just talked about.
So what does 2,000 actually buy, done right?
The honest, real-world €2,000 build is 2 used 3090s, 48 gigabytes between them. That runs a 70 billion model properly at about 14 to 16 words a second. That is a genuinely serious home AI box for $2,000 that'll embarrass a lot of cloud subscriptions.
Okay, but hang on. Devil's advocate. If 2 cards is good, isn't 6 cards 3 times better? Why not just keep stacking?
This is the best myth in the whole episode, because the answer is no. For one person chatting, 6 cards is not 6 times faster. It's barely faster at all.
How is that even possible?
Because of that reading speed thing again. When you split one model across several cards the normal way, only one card is actually reading at any given moment. The others sit there waiting their turn. So your speed is still just one card's bandwidth. The rest are along for the ride.
So the extra cards aren't making it faster. They're just holding more.
That's exactly it. More cards buys you 2 things: capacity so you can load a bigger model, and throughput so you can serve lots of people at once. What it does not buy a single user alone is a faster reply. That one sentence saves people €1,000.
So when would 4 cards actually pay off?
When it's not just you, a household, a small app with real users. 10 people hitting it at once, 4 cards handle all 10 in parallel, and now the extra hardware earns its keep. But for you on your own, talking to it, one good card feels about the same and costs a quarter as much to run.
Speaking of running it, what does a 4-card box actually pull at the wall?
For 3090s is around 13 to 1500 watts under load. That's a bar heater. In America, on a normal wall socket, you can literally trip the breaker. It's hot, it's loud, it needs a special power supply and real airflow. It's a beautiful machine. It is not a toaster you leave humming on the desk next to you.
So the takeaway on building?
2 good cards, not 6 cheap ones. By capacity only if you actually need the bigger model or the crowd, and respect the electricity. Most people should stop at 1 or 2 cards and never think about it again.
All right. What if I just want to buy something new? Off the shelf. Warranty. No mining card gamble.
Then I've got bad news about timing. Right now is one of the worst moments in years to buy a new graphics card. There's a memory shortage, the factories can't make enough of the new stuff, and prices have gone haywire.
How haywire are we talking?
The flagship, the RTX 5090, has a sticker price of $2,000. It's actually selling for around $4,270, about €4,000. That's 114% over the $2,000 sticker, more than double.
That's for one card?
For one card, and here's the kicker that makes it worse for our purposes. That $4,000 flagship only has 32 gigabytes, which means it still can't fit a 70 billion model at 4-bit. You'd have to squeeze the model down further and lose quality.
And the cheaper new cards?
This is the cruel part. The mid-range new cards, the 5080 and the 5070T, launched with only 16 gigabytes. For gaming, fine. For AI, 16 is the wrong end of the pool. It can't hold a 32 billion model, so the new stuff is either too small or too expensive, or both.
So the $4,000 card loses to 2 used cards that cost $1,500 together.
For AI at home today, comprehensively, 2 used 3090s give you more memory, run the bigger model, and cost a third of the price. The only reason to buy the new flagship right now is if you also want to game at the absolute top end. For pure AI this month, it's a bad deal. Wait for the shortage to ease or buy used.
Let's talk about actually living with one of these, in the room. because a spec sheet doesn't tell you what it's like at 11 at night with it running.
Right, and this is where the quiet options quietly win. A gaming card running hard is basically a hairdryer. A single 3090 pulls 350 watts and blows hot air. 2 of them and your office is warm in July. It's fine, but you will hear it and you will feel it.
And the running cost? The actual electricity.
Added up, a card pulling 350 watts a few hours a day is real money on the bill across a year. Not enormous, but real. Now compare. One of those unified boxes or a Mac doing the same job sips maybe 150 watts in silence. Over a few years, that gap adds up to a card's worth of money.
So for something you leave on all the time.
For an always-on assistant, the quiet, efficient box can genuinely be the smarter buy, even though it's slower. You're not racing anything. You just want it there, humming along, not heating the room and roaring at you.
So speed isn't the only score.
Speed is not the only score. A screaming 4-card rig is thrilling for a week. Then you move it to the garage because you can't think next to it. Buy the version you'll actually keep on your desk. That's the one that gets used.
Okay, completely different direction now. Because you keep saying the fast memory is small. But I've seen people running the absolute biggest models on, of all things, a Mac.
And this is the other whole side of the trade, unified memory. The Mac idea, and now a wave of little boxes copying it, is don't bolt separate memory onto a graphics chip. Just give the whole machine one giant pool of memory that the whole thing shares.
And that pool can be huge.
Enormous. Apple's top Mac Studio could be ordered with 512 gigabytes in one quiet little box on your desk under 200 watts. That machine can load one of the giant open models, the ones with hundreds of billions of parameters. A multi-$1,000 graphics rig can't even hold those.
So that's the win. Capacity.
Capacity at low power and silence, that's the whole pitch. But remember the trade. That giant memory is the slower kind. It reads at about 800 gigabytes a second, which is roughly one used 3090. So it holds a model 20 times bigger but reads it at gaming card speed, not 20 times faster.
Can you just rank them for me? Simply, by that one magic number.
The bandwidth ladder top to bottom. The new flagship 1700 gigabytes a second, a used 4090 about 1000, a used 3090 936, the Big Mac 800, a Mid Mac 550, the 3060 360, the trendy new mini boxes 270, and your plain desktop 90.
And that order is just the speed order.
Top to bottom, best to worst for how fast the model talks. Tape that ladder to the wall and you never need another benchmark. You already know which is faster. It's just which one can you afford and does the model fit.
So on a normal 70 billion model, a Mac isn't actually fast.
A 70 billion on that Mac is around 12 to 15 words a second. Fine, not amazing. A pair of 3090s beats it. Where the Mac wins is the models that simply won't fit anywhere else at a price and a power bill a graphics rig can't touch.
And there was a second catch you mentioned, about prompts.
Yeah, and it matters. Reading back a model is one job, but chewing through a long prompt you paste in, that's a different job, and that one does lean on raw compute, and that's where the Mac is weak. A real graphics card digests a big document in a second. A Mac can sit there thinking for 10, 20 seconds first, so for short chats, lovely. For dumping a whole code base in, less lovely.
And the different Macs. Because 500 gigs sounds expensive.
It is, and honestly, the very top config got pulled during the shortage, but you don't need it. A Mac Studio with 128 gigabytes is around $3,500, say €3,200, and runs anything up to a 32 billion model beautifully, plus the mixture models. And a Mac Mini, 64 gigabytes, about $2,000 or €2,000, is a lovely little always-on machine for the small and mid models.
Now, the thing that made all this suddenly click for me. You said the newest models change the maths.
This is the clever bit. The newest big models are what's called mixture of experts. The trick is the model is huge, but for any single word, it only switches on a small slice of itself. So you pay for the big memory to hold the whole thing, but the reading speed is set by the small slice that's actually awake.
So a giant model can run faster than a smaller old-style one.
Genuinely, yes, one of these 600 billion mixture models on that Big Mac runs at around 16 to 20 words a second, faster than a plain 70 billion on the same machine. That's the thing that makes the big quiet boxes suddenly worth it. The model's bent toward exactly what they're good at.
Okay, and the new box is copying the Mac, the NVIDIA one, the AMD ones.
So this year there's a rush of little unified memory boxes. NVIDIA's is called the DGX Spark. AMD's turn up as things like the Framework Desktop. Both give you 128 gigabytes of shared memory.
And what about the prices?
The NVIDIA box is about $4,700, say €4,300. The AMD ones are far cheaper, around $2,000 or €2,000, and that price gap tells a story because on paper they look similar.
So which is the better buy?
Here's the receipt. Both of them read memory at about 260, 270 gigabytes a second, which is, remember, about a third of a used 3090. So they are capacity boxes, not speed boxes. On a normal 70 billion model, NVIDIA's $4,700 box does under 4 words a second.
Under 4? For $4,700?
On a plain 70 billion, yes. They only look good on those mixture models, where even the cheaper AMD box does a very usable 30-odd words a second. So if you buy one, buy it to hold a huge mixture model quietly. Don't buy it expecting graphics card speed. And honestly, the $2,000 AMD box is the interesting one. The $4,700 one is a much harder sell.
And the last flex I've seen online, stringing Macs together. Is that real or a party trick?
A bit of both. You can now link several Mac studios with a fast cable and run one model spread across all of them. And it works. Somebody chained 4 of them and ran a 235 billion model, going from about 20 words a second on one to 32 across 4.
That's a real speed up.
It's real, but it's modest and it costs a fortune. 4 of those Macs is $30,000 to $40,000, call it 35,000 euro. So it's a capacity play for someone who needs to run the very biggest things privately at any cost. It is not the cheap path. Nobody watching this needs to chain 4 Macs, but it's a glimpse of where the big quiet boxes are heading.
Okay, let's make this real. Because numbers are numbers. If I spend the money, what do I actually get to do? What runs on what?
Great question, because the answer's better than people expect. Start at the bottom. Your $200 12 gigabyte card, that runs a modern 8 billion model, and an 8 billion model today is genuinely useful. A smart assistant. It'll help you code, summarize a document, answer questions, draft an email. All offline, all private, nobody logging it.
On a $200 card.
On a $200 card, step up to the 24 gig 3090 and you're running 32 billion models. And that's a real jump. That's serious coding help, proper reasoning, the kind of thing that felt like magic from the cloud a year or two ago. Running on your desk for the price of a games console.
And the 2 card, 70 billion box?
Now you're into near frontier. A good 70 billion model is close enough to the big paid ones that, for most everyday work, you would not feel the difference. Writing, coding, analysis. That's the 2,000 euro box doing work people pay monthly subscriptions for.
And the big unified boxes. The big memory Macs.
Those run the giant mixture models, the open ones that genuinely rival the flagship cloud models. The stuff that 2 years ago only existed inside a data center. Now it's a silent box beside your monitor. That's the headline of the whole local AI movement, really. The gap between what you run at home and what the labs sell you has never been smaller.
Paint me a day then. What does living with this actually look like?
Sure, morning you paste yesterday's messy notes into your local model. It hands you a clean summary. Never touch the internet. Midday you're coding, and a 32 billion model on your 3090 is your pair programmer. No monthly fee, no rate limit, no outage. Evening the kids want a bedtime story about a dragon. The same box writes it and draws the dragon too.
All on one card, in the corner of the room.
One card humming quietly, doing the work of 3 separate paid subscriptions. And nobody anywhere saw a word of it.
And it's not just chat, is it?
Not even close. Same hardware runs image generators, voice models, the kind that talk back and sound human, models that watch a video and describe it, little agents that click around your apps and do tasks for you. It is all the same gear we've been pricing up, a graphics card or a box of shared memory. That's the whole toolkit.
And the models themselves. Are the free open ones actually any good now? Honestly?
That's the part that snuck up on everyone. The free models you run at home have caught up frighteningly fast. The best open ones today trade blows with the paid cloud models from a year ago, and a new better one lands free every few weeks. You don't buy the model, you just download the newest one. The hardware is the only thing you pay for, once.
Alright, practical. Say I buy the card. How hard is it actually to run this stuff? Because I remember it being a nightmare. Command lines, errors, the lot.
It used to be exactly that. Python errors, dependency hell, a weekend gone, that's over. In 2026, it's genuinely a 2-minute job.
2 minutes, that's it?
There's a free app called LM Studio. You download it like any normal program. It's got a little built-in store of models. You click one, it downloads, and you start typing. It looks like any chat window. Your gran could do it.
No command line at all.
None, and if you want to wire AI into your other apps, there's another free one called Alama. It quietly runs models in the background so anything else on your machine can talk to them. One line to install, and it just sits there working.
And underneath all of it?
Underneath is a free project called llama.cpp, that's the actual engine. A handful of volunteers built the thing that runs AI on almost any hardware on Earth. A gaming card, a Mac, that mad AMD server card, even an old laptop. It's one of the quiet miracles of this whole scene, and it costs nothing.
So the software isn't the barrier anymore.
The software is solved, free, easy, runs on everything. The only real question left is the one we've spent the whole episode on. What do you run it on? And that's hardware.
Which is why this is the episode that matters.
That's why we made it.
Give me the literal first steps then. Tonight, what do I actually do?
Download LM Studio, open it. In the search box, type the name of a small model in 8 billion one. Click download, wait a couple of minutes, then type hello, that's it. You're running AI, local, private, free. The whole thing is a 15-minute job, and most of that is just the download bar.
Let me push on the money though, because a €700 card is real money. A cloud subscription is $20 a month. So why buy?
Fair question, and it's not always the right call, but run the numbers. $20 a month, near enough. €20 is $240 a year, forever. A used 3090 pays for itself in under 3 years, and then it's free for as long as you own it, and it's actually yours.
And it does more than the one thing.
That's the bit people miss. That one card isn't just a chat bot. It's your image generator, your voice model, your coding assistant, your video tagger, all of it, all local, all at once. You're not renting one service, you own the whole workshop.
And then there's the privacy side.
For a lot of people, that's the whole reason. Your conversations, your documents, your code, your business, none of it ever leaves the room. No company training on it, no log sitting on someone's server, no terms of service that quietly change next Tuesday.
So it's not just cheaper.
Cheaper over time, more capable and private. That's the honest case for local. It's genuinely not for everyone, but it's a lot more people than the cloud companies would like you to believe.
Okay, my head is full of numbers. Bring it home. Somebody watching wants to start tonight. Just tell them what to buy.
Write 4 honest answers by what kind of person you are. 1. You're curious, dipping a toe, running the small models. A used RTX 3060, 12GB, $200, about €200. Done. Best first step there is.
Okay, what's number 2?
2. You're serious, you want 30 billion models fast with room to grow to 70. A used RTX 3090, around $700, €650 to €800, or 2 of them later for the big models. This is the sweet spot for most people. If you buy one thing, buy this.
And what's number 3?
3. You want to run the absolute biggest models. You care about quiet and low power more than raw speed, and you've got the budget. A Mac Studio or that cheaper AMD unified box. You're buying capacity and silence, not speed. Just go in knowing which one you bought.
And the last one?
4. You're a tinkerer, you love a project, you want the most memory for the least money. The Mad MI50, $150, €140, 32 gigabytes. You will fight the software, and you will love every minute of it.
And the one thing not to do?
2 things, don't buy a brand new flagship this month. The shortage has turned it into a rip-off. And don't go chasing the old Tesla cards for cheap memory. That door is closing this year. Use 3090 or unified memory if you truly need the size. That's the whole map.
So the real headline of the whole episode is?
You do not need to be rich to run AI at home. A $200 card gets you through the door, and the thing you need to understand isn't a brand or a benchmark, it's one idea. Does the model fit in the memory? Then, how fast is that memory? Everything else is marketing.
And where's it all heading before we go?
Toward the big quiet boxes. Look at the trend. This year's unified boxes read at about 260 gigabytes a second. The next AMD generation is already projected at 400 to 700. That's the whole story, that one number climbing.
Because that's the number that was holding them back.
That's the bottleneck closing. Pair that rising bandwidth with the mixture models that only wake a slice of themselves, and the big quiet box stops being a compromise. The screaming 6-card space heater is the present. A silent brick on your desk holding a giant brain, sipping 100 watts is the direction. But today, a used gaming card is still the smart money.
If you want the full list, every card, every price, every speed we quoted, it's all in the pinned comment, with links. Sourced, like always.
And if a price has moved by the time you're watching this, and it will have, tell us. This stuff changes weekly. We'll keep it honest.
This is the audio side of the Off the Cloud AI channel. There's a whole video series that goes deeper. The explains ones, if you want the how it works, and the hype check ones, if you want the claims taken apart.
All of it run locally, no cloud, on exactly the kind of modest hardware we just spent half an hour talking about.
So go build something. You've got a lot less excuse than you thought.
That's the difference between hype and facts.
Off the Cloud.